I'd say he's coming all the way from St. Paul, Minnesota, but he actually came back from Australia, went home, did his laundry, and then came out here. So next up we have Jeremy Wagner. You might know him from Web Performance in Action because he wrote the book. If you read the book, you wouldn't even need to be here because he covered almost all of it, or not quite. Things have actually progressed a lot, so he's going to talk to you about demystifying all those performance timings that he may have mentioned in the book. I haven't read it yet, so I have to go do that.
So you
go to Arrangement.
Arrangement. Oh.
And there you go.
There we go.
And so without further ado, before he's even ready, let's give it up for Jeremy. You ready?
You're
good. You're good.
I gotta like maximize my window. I can't see
That's actually good enough.
Okay, cool.
Yeah.
We'll just roll with it.
I'm just going to actually put this here.
Okay.
Give us 30 seconds.
Sorry. I'm working on it. It's happening.
We have lots of experience in running conferences. Like, this is our first one.
All right.
All
I think I'm ready. Okay. Hi, this is a talk about demystifying performance timings. So this is pretty cool, right? Who has worked with navigation and resource timing in the browser with JavaScript APIs? All right. How many of you would say that, like, you're really good at it? Me too. I'm not very good at it, but, you know, I did a thing. It's called reading a spec. And I don't read enough specs. I probably should read more. But reading the navigation and resource timing specs really helped to make it clear to me how all of these things work. Before I get started, I want to introduce myself. My name is Jeremy Wagner. Estelle said all kinds of stuff about me. I'm here to just sort of be your performance jester for today, I guess. So let's see what happens. But first, I want to talk a little bit about how we test applications for performance. Because testing is important, right? Like, how are you going to assess performance without testing? The first thing we think about is synthetic testing, right? Or what we like to call lab data. And this is a good kind of testing to do. It's stuff that you do in your browser, right? So, for example, Lighthouse, which is in Chrome, it could be more simple than that. You could simply just go to your network panel and just, you know, look at how many bytes are being thrown down the wire and what your assets are and all that kind of stuff and how long it takes. You could use sitespeed.io with Grafana if you really wanted to get fancy and graph these things out over time. But it's still synthetic, meaning that it's testing that we do that doesn't account for other users. It's a narrow view of performance for our application. And that's fine because it's useful. The case for it is that it's really easy to do. You can spin up Lighthouse, you can run it a few times and get some basic data and find out what's going on with your application. It's great for spot checking performance in dev environments with network throttling, of course, because localhost has, you know, very little latency. Maybe you're on a corporate network, but that's still, you know, not really much latency. So of course you should be network throttling if you are doing any kind of synthetic testing on your local machine. It's easy to measure the effect of code changes on performance due to consistent baselines. And I like this because if you're on a relatively stable connection or if you're just doing network throttling on localhost, it's nice because you can easily measure the effect that performance tweaks have, right? The problem is it doesn't necessarily reflect what real users are experiencing. And that's kind of a bummer because that, like, as I've said, that synthetic testing is a very narrow view of your application performance. And that's where RUM comes in. And no, not, but as an aside, how many times has this joke been made? I know, but I couldn't resist. No, not this, because not only is Admiral Nelson's RUM garbage, it means something else entirely. What we're talking about is real user metrics, or what we might call field data, meaning data we get in the field, right? So the case for that is pretty self-evident. You're gathering metrics from real users who are using your site or app, and that's awesome because you can see what's going on as your users are using your app, and you can see the effect of your application performance in real scenarios because you're gathering data from those users. The case against, however, is that it's just not as convenient. Whereas with synthetic testing, you could just plunk open the dev tools and run Lighthouse or what have you. In this case, you have to write some code Or at the easiest, you use a third-party service that automates this for you, but that costs money, and if you have money, that's great. But maybe you just want to write code and figure this out. That doesn't mean you shouldn't use it, though. But it is it can be kind of complex. I mean, this looks simple, right? I mean, this is just something you could plunk into your console that would get you all the navigation timings for a page after it is loaded. If you wanted to get resource timings, you could just change navigation to resource. Either way, when you get that and then you do that console.dir to see what that looks like, and you go, like it just kind of stares you in the face, and it's like all of these metrics, and it's difficult to know without reading a spec or without really knowing a lot about network architecture and inferring what these things mean. It's really hard to know, and it just kind of makes you really sad because you went in thinking, all right, I'm doing these APIs, this is really cool, I feel really smart, and then all of a sudden you don't feel very smart anymore. But no worries, we're going to talk today and we're going to demystify some of these timings. I'm going to give you some recipes, some simple arithmetic type stuff where you can measure specific phases, and if we have some time, I might even go over the DVD bonus extras of stuff like server timing and paint timing, which is really, really short, but we'll see if we have time. I want to quickly define the differences between these two APIs. Navigation timing gathers page metrics, meaning usually HTML documents, although a document context could be different. Normally we're talking about HTML, but if you access a CSS file directly, it has a document context. Therefore, it will have a navigation timing entry, at least so when I tested a little while ago. Things change all the time. Resource timing is when we're gathering resource metrics, and these are page-dependent resources, things that your HTML document is bringing in, such as CSS, JavaScript, images, and etc. And so what helps me understand, or rather what helped me to understand how these timings work, was to look at the processing model that you see here is linked in the navigation timing level 2 spec. And so when I saw that, it was kind of like it all became very, very simple to me all of a sudden, and I thought I should submit a talk on this. And then joke's on everyone here, they picked this talk, so here you go. Now we're just going to roll right into it from unload all the way to load, and we're just going to go sequentially and talk about each one of these phases and some of the metrics therein, although there may be a metric or two that doesn't make the cut. So if you see something in the console that doesn't pop up here, I'm sorry. I'm just trying to make this palatable. So first, unload is when the document unloads. And unloading is, basically anytime you kick off a navigation, a document has to be unloaded, or a current document has to be unloaded. And when this occurs, it can be canceled. A user could say, I don't want to do this, they hit escape, or they close their browser, or any number of things. Say they get a prompt that says, are you sure you want to leave this page? And then they click, no, I don't want to leave this page. Then that's a canceled unload event. But unload metrics are pretty simple. We have start time, which is not necessarily part of the unload phase itself. It's actually the beginning of the entire navigation timing phase, and it's almost always 0. Or rather, it is always 0 because, if you're measuring time, you got to start from 0. But the two events here that are of importance are unload event start and unload event end, and they are pretty much what you would think. Unload event start is when the unload event starts, and then I will leave you to figure out what happens on unload event end. Regarding these metrics, as I said, start time is always 0. Like I said, if you're measuring time, you got to start from 0, so that makes sense. Unload event start may be 0 if there is no previous document, or if a previous document or redirect is not from the same origin. And that's important to know, because if you're coming from like about blank, or you're coming from an origin, a different origin, and maybe it doesn't have the timing allow origin set or header set, then you may see that as 0. Otherwise, it may be greater than 0. Unload event end can overlap with other events later on that we'll talk about, such as connect, redirect, and maybe not necessarily response or request, because that's pretty late into it, but it's possible because as the document is unloading, the browser's trying to do things as efficiently as possible. So it may actually start to kick off connection requests before unload event end has actually occurred. So understand that these, while they're presented sequentially, they're not always necessarily sequential. There may be some slight overlap. Next, we'll talk about the redirect phase. And redirects are important, right? It's when a navigation encounters one or more HTTP 300 level status codes. And where performance is concerned, this is kind of important because we can be left sort of chasing our tail if there are too many redirects. And this is what it looks like sort of visualized. As you can see here, this is a short link off of my domain that goes to my book page for my Manning book. And you can see it goes through a number of redirects. If it hits from an insecure context, it redirects to the secure context, and then it redirects to another domain, and then that's in the insecure context, and then that redirects to the secure context. So it's important to measure these things because these can be, these can significantly impact performance, so you might want to know a little bit about it. And the phases here are really simple. It's redirect start and redirect end. It's extremely simple. And it's also worth noting that the resource timing API processing model actually begins here. There isn't an unload event for resources, as there are part of the document, or they're rather document dependencies. So let's talk a little bit about redirect metrics. Redirect start and redirect end will be 0 if no redirects occur. Makes sense, right? If we can't measure a redirect because there isn't one, it's going to be 0. And redirects from and to other origins can still come up as 0 if the timing allow origin header isn't set. Timing allow origin is a header that you can set that will allow other origins to collect resource and navigation timing metrics. So if this isn't a header that is set, you may not be able to actually measure that information. Next, we're going to talk about app cache, and this is a somewhat oddly named phase, but really what it is it's when the browser begins to fetch an item, and it's inclusive with whether or not a browser needs to fetch something from a cache. And when we're talking about fetchStart, we're talking about as soon as it begins to fetch an item, including the cache. And it's just this one metric. It's fetchStart. That's when it begins fetching. And the app cache metrics are a little, app cache metric, I should say. It's a little bit fuzzy. Regardless of caching, fetchStart can begin at about the same time, meaning that whether or not an item is being retrieved from a cache or whether it is getting retrieved from the network, fetchStart will signify right around the same time when that request is being made. If an item is cached, metrics that come after fetchStart, such as connectStart, especially network-dependent performance metrics such as requestStart, connectStart, response end, all of that stuff, will occur very nearly after because no network request was made, so there's not really any network activity of note to measure. So let's take a look at this, right? So we have at the top an uncached resource, and you can see that both fetchStart occurs at about the same time for the cached and uncached resource, but you'll see on the bottom for the cached resource that all of those other phases are kind of condensed because there really isn't as much network activity, if any. Next, we're going to talk about DNS lookups, and we've already talked about DNS lookups in some other talks before. DNS lookups, of course, as you know, is when a domain name is resolved to an IP address, and that does take a little bit of time. A request has to go out to a DNS server to make this lookup and find out what the IP is, and that can take a little bit of time. In this case, it's just 25 milliseconds. It's not a ton of time, but it can extend. I mean, as latency increases, as network quality degrades, this can take some time, and you might actually want to measure this phase of your applications. Again, a very simple part of the processing model. It's just domain lookup start and domain lookup end, self-explanatory. But regarding these metrics, there's really just one key point. It's that DNS lookups can be cached at multiple levels. I used to think it was just like a system cache or maybe a cache at your ISP. There's actually quite a few things. It can be cached in your browser. If you go into Chrome's net internals and you go to the DNS section, it will show you a list of all of the DNS entries that are currently in the browser. There is the system DNS cache, which I'm sure if you're on a Windows machine, maybe you've run ip config/flush DNS. That's what it is flushing out, is your system DNS cache. Your router can have a DNS cache. ISPs can have their DNS cache, and at any number of levels and different servers may also cache those entries. And the reason why that's important to know is because if you have DNS lookup times that are extremely small or 0, that could be a cache for a user playing a part in that role. So next we'll talk about connections, and this is when network connections are established to a remote server. And as Yoav had talked about, there are a number of things that go on when this happens. We're talking about when the TCP handshake occurs, and inclusive to this phase is the TLS negotiation time, which I will get into that metric as well. And you can see that both of those are represented in this DevTools little flyout in the network panel with initial connection and SSL. So the connection phase is a little bit more complex. It's similar in that to other phases in that we have a start and an end, connectStart and connectEnd, but there is this kind of weird little one called secure connection start. And that's when your secure connection, your TLS negotiation is occurring. So regarding these connection metrics, connections can be reused. There is a thing called keep alive where you might be able to reuse a connection, or there is HTTP2, which is actually streaming all of these resources over one connection. So resources may not actually show much in the way of connection metrics unless it's for a cross origin, perhaps, like Google Fonts or that kind of thing, or any kind of CDN. Secure connection start will be 0 for non-secure sites. And that's important to note because even though we should be using HTTPS, there are quite a few servers out there that don't. But it could also be 0 if TLS sessions are resumed. I know on my server I have a TLS session cache that I have set up in Apache, and if that session is resumed, then that secure connection start can be 0 because an optimal thing is happening. That session is being resumed to lower latency and improve performance. Next, we're going to talk about request and response metrics, and that is when requests are made and responses occur. This is visualized again in Google Chrome. You've probably seen something like this, and what we see here is when the request is sent, which usually doesn't take a lot of time because we're uploading a very small amount of data to make a request to a server. But then the one that we do like to measure, this is kind of these metrics that always come up, is time to first byte, which is the amount of time it takes for a response or for the first byte of a response to come after we've made a request, and then the amount of time it takes for that content to download. And this is represented in the navigation and resource timing APIs through request start, response start, and response end. And you might notice that there isn't really a request end because that's not really as significant as the entire process is. So if we want to measure the latency between the start of a request and the start of a response, we can just subtract those two things. And then, of course, we could measure how long an asset is taking to download by looking at response end, which I have a couple of recipes regarding these things that I'll show you in a little bit. Oh, and of course, because the resource timing API model begins somewhere, it has to end. And it ends here because the next phase is the DOM processing phase, which only applies to documents, which is only a part of the navigation timing API. So regarding these fun request response ping-pongy metrics, request start obviously denotes the start of a request. I'm saying some really obvious stuff here. Response start and response end denote the start and end of a response respectively. Great, I just repeated myself. That's okay, these things happen. Processing, when the DOM is being processed. And this is important because there's an amount of time that it takes for the browser to be able to break down a document and to tokenize HTML tags and to discover other resources and to populate the DOM. It is a significant amount of processing that can occur, and if you have very large and complex DOMs, maybe you want to measure that, right? Like maybe you want to know how long it takes for your DOM to become interactive, how long DOM content loaded events start and end takes. I mean, when we bind or check rather for document readiness, we are checking for DOM content loaded, and that's part of that. And you may want to know when the DOM is actually complete, which is when everything has loaded. So regarding these processing metrics, domInteractive marks when the browser has finished HTML parsing and DOM construction. And DOM content loaded event start and end marks when the DOM is ready. As an aside, I can never say DOM content loaded without having to really slow down a lot. And domComplete marks when everything is loaded. That includes all page-dependent resources, but it's not the same as the load event, which we'll talk about here in a second. And continued on these processing metrics, domInteractive and DOM content loaded event start occur around the same time. There might be a little bit of latency in between them, but they generally occur fairly quickly after one another. And depending on your front-end architecture complexity, domComplete can often occur sometime after DOM content loaded event end has occurred. And you can see here, this is from the timing API from, I forget where I took this from, if it was my site or New York Times, probably my site. So you can see here that domComplete occurs quite some time after DOM content loaded event end, and that's fairly common because the DOM is often ready and constructed before everything on the DOM has loaded, like all the images and all that stuff. And finally, the last portion of the content model, or rather the processing model, is the load event. And that's when the page has loaded everything, hopefully better than this, because that would be, I don't know. Anyway. Load event start and load event end signify the beginning and the end of this phase. And really, there's only a couple things you really need to know about load metrics. And it's that load event start will usually occur briefly after DOM complete. They're very similar, but they're distinct. And load event end signifies when the page has utterly and completely finished loading. And that's the processing model. That's pretty much it. But I'm not done yet. There's some other stuff. I got some little bits here. There's some other time-related metrics, or rather pieces of information that these APIs expose. And the first one is name, and that will be the URL of a document or a resource. So if you are checking for a particular resource in your JavaScript that you want to monitor performance of, this is kind of what you'll check for. This will be the little bit of data that you're trying to hook on. Transfer size is the size of a resource, including headers. We often tend to forget about stuff like headers, right? Like we look at our images on the disk and we're like, oh, that image is 25,000 bytes, for example. But what we forget is that headers actually comprise a little bit of data, or sometimes a lot of data, depending on cookies and other headers that you might be sending, of a total response. There's the response headers and the response body. So when you look at the size of something on disk, all you're really looking at is the size of a potential response body. Compression notwithstanding, of course. Speaking of compression, you can look at the encoded body size metric to see what the size of a resource is without headers, which is kind of cool, right? And I have a recipe that I can show you how you can measure headers using this. The decoded body size is the decompressed size of a resource. And this is important because there have been some articles written, particularly one by Adi Osmani, on the cost of JavaScript startup time. And we often think that, oh, 200K of JavaScript, gzipped, when it's thrown down the wire is 200K. I mean, that's still a lot of JavaScript compressed, but when that gets decompressed, that could be like a megabyte. And a megabyte of JavaScript is a lot because the browser has to compile and parse it, has to do all of these different things in the engine before it can execute it and make that ready for the user, for user interaction. And so maybe this is something you want to look at, particularly also for CSS resources as well. Next hop protocol is the protocol that's used to transmit a resource. This may or may not be of some importance to you, depending on what you care about in your metrics, but I think it's kind of neat. The values that you will commonly see are H2 for HTTP2, HQ for quick, although you'll see this somewhat less commonly until quick becomes kind of more mainstream. In HTTP 1.1. It's worth mentioning that this is probably not an exhaustive list. You might see HTTP 1.0 or 0.9. I don't know. I've never seen that in the wild, but if those protocol versions are out there, I have to think that they're represented in this list, most likely. And you might want to measure this because there are a subset of users, even if you're using HTTP 2, such as users on Opera Mini, for example, which sees fairly broad usage in some developing nations where prepaid data can be kind of expensive. That doesn't support HTTP2, and maybe you want to measure how many of these, like what percentage of your audience that segment is. And so then maybe you could decide whether or not you want to change your resource delivery strategy to cater to those users because they don't benefit from lots of requests that HTTP2 accommodates and that kind of thing. And next, we're going to talk about timing recipes. These are fun because it's just simple arithmetic. You don't have to break your brain to understand how they work, but they're really useful. So if you want to measure time to first byte, as I had said before, time to first byte is simply the difference between when a request starts and when the response starts. So you simply just subtract request start from response start, and you'll get kind of a value. So you could actually aggregate time to first byte from many different resources for your users, and that might be really useful. You could measure total resource fetch time. Say you have a particularly critical image or resource that you want to measure and you want to see how fast it's being downloaded for users. You could simply subtract fetchStart from response end. This one's a little bit more complicated, and it may not be entirely accurate, depending on what you consider fetch speed to be. But the way that I've kind of calculated it is that I will take the transfer size, which is the total size of the response, including headers, and I will divide that by 2 to the 20th, which is a megabyte represented as bytes, so 1,000,000 some odd bytes. And then I will divide the difference between the response start and the response end, the total time the response takes to download, and then divide that by 1,000 to get that in seconds, and then by dividing that transfer size in megabytes by the response time in seconds, and then times 8, because there's 8 megabits in a megabyte, we can get a rough sort of guide for how long, or like what kind of throughput or bandwidth your user has. Now that said, maybe you might take this a little bit, you might think I'm taking this a little bit too literally. Maybe you would prefer to subtract fetch start or request start from response end. It just depends on how you want to measure that. I feel like this strictly measures in-flight asset bandwidth fairly well, even if it's a little bit constrained. Header size, if you just want to see what the size of headers is, or headers are for a particular resource or document, you can simply subtract encoded body size from transfer size, and you will get the size of the headers. In this case, it's not a lot, it's 169 bytes, but hey, if you have a lot of weird authentication tokens and cookies and that kind of stuff that you're throwing around in headers, maybe this will be useful for you to find out exactly how much your headers are taking up. And DNS lookup time, pretty simple. Domain lookup start subtracted from domain lookup end. That's it. And same with TCP time. connectStart subtracted from connect end to find out how long that connection is taking. Although this particular recipe is inclusive of SSL time. So if you wanted to break out SSL time, you could do this, although I could represent this with a ternary, but I decided not to because I would have had to scroll and I didn't want to do that. You could simply set your SSL time in a variable as 0, and then you could check to see if secure connection start is greater than 0. And then you could then subtract secure connection start from connect end, and then you'll have your SSL time, which in this case is a not so insignificant 58 milliseconds, depending on what you consider to be insignificant. And DOM processing time, it's pretty simple. Subtracting domInteractive from domComplete, and you can get that whole DOM phase figured out just in one go. And I should mention that this is all kind of pseudocode. If you experiment with this in the browser, it's going to look a little bit different because you're going to have to loop over different resource timing entries to kind of figure this stuff out. But that wouldn't fit neatly on these slides, and I loathe scrolling, so I didn't want to do that. We got some bonus materials. We got time for the DVD extras. I made it only because I chatted at such a frantic pace. So this is a cool one. I really like this a lot. It's called server timing. And what it does is it passes server-side metrics that you calculate on the back end of your application, and it passes it to navigation timing. And maybe you saw in the initial screenshot of a navigation timing entry earlier on that there was this server timing object that wasn't expanded. And that's when you bring in server timing headers, that's where they get populated into, is in the navigation timing API object, or at least in that space. What these headers look like depends on how you construct them. In this example, I just have 2 headers that are separated by a comma. The first token in the header is the name of that metric. DUR is the duration, although I would say please round, because that's a lot of extra bytes to be sending for no reason. Maybe I should have rounded that, but I was kind of lazy at the last minute and I didn't want to take that screen cap again, so this is what you get. Description is a human-readable description of your metric. In this case, it's just a nice, friendly label that comes up. And you can see here that I have another thing for MySQL timing because it was a MySQL backend for a database. And what's great about server timing is that it gets visualized like this. If you see a document that has server timing in Google Chrome, if you hover over and you get that timing information, the flyout that shows stuff like your DNS time, your connection time, all that good stuff. then this will come up too if you have server timing headers, which is really cool. It kind of blew me away because I stumbled on it by accident, and I was like, "Whoa, this is so cool. All of this stuff is just there because I just populated it on the server, and the browser just decided to visualize it for me." And what you see here, those labels are those human-readable labels from the description attribute, or rather, I'll just call it an attribute. But yeah, you can make those human-readable, and they're pretty cool. Paint timing API, which is really exciting. I haven't used it a lot, but I think it's pretty neat, and I hope it gets expanded because it's currently only 2 metrics, which I'll talk a little bit about. It's easy to try in the console, but I should warn you, it's only available in Google Chrome so far, as I know. As is server timing, I believe. I could be wrong about that. It's pretty simple. You can just loop over this stuff after the document has been loaded. You just loop over this stuff and use get entries by type with a value of paint. And if the browser supports paint timing, with this code, you'll get something like this in your console. And you'll see that there are 2 different metrics. And as I said, I would like to see this get expanded a little bit more. But there is first paint, which is the moment in time that anything has been painted to the page, whether it is meaningful or not. It could just be layout or whatever. And then there's first contentful paint, which is supposed to be the time that anything meaningful has been painted to the page, such as text or images. I found that these 2 metrics tend to be the same, but I have witnessed certain documents where they're not. So it is attempting to measure the first meaningful paint. But what I would say is that I would assume that this is still in development because it's kind of new. And I'm also hoping that we get some other metrics in there, maybe some stuff like speed index, although I don't know how feasible that is or if it even fits into paint timing, or other paint-based metrics. And lastly, we'll talk about the long tasks API. And this is activity that blocks the main thread for a long period of time. But what's a long period of time? The spec says that a long task refers to an event loop that exceeds 50 milliseconds. And that's significant, right? Because if you have a blocking task on the main thread for 50 milliseconds, that's going to cause what we call jank, because you have a budget of about 10 milliseconds per frame in an application. And so 50 milliseconds could significantly delay rendering or cause that jitteriness that makes an app feel kind of cruddy and bleh. And to use it, you have to use a performance observer, I've found. And in this case, what I found is that if you're trying to use this in the console, this isn't going to output anything if all the long tasks have been detected after initializing the observer. So you may have to actually just put it on a page to kind of play with it. But if you do this, and you'll notice here, the good stuff is that entry type long task. And that's what you'll look for when you're using something like get entries by type or get entries. And those metrics are kind of cool. You'll get the duration of the long task. You'll get where it comes from, if it came from a script, the container type, things like that that are important so that you can kind of suss that out and debug those things and get those long tasks to be short tasks because we want short tasks. Or we could offload them off to another thread, hopefully. And some quick tips before I leave you. Don't record computed metrics. This is more of a tip for me. If you know what you're doing, go ahead. But what I don't like about recording computed metrics is that once I've done that, once I've like calculated all my phases, then it's kind of, the genie's out of the bottle, I guess. You can't really kind of pack that back in if you want to do some other, computing of metrics. So if you don't know what you're doing, just record the raw metrics and do your arithmetic later. And always feature check. You can't assume all this stuff is available in the browser. You're always going to want to check for the performance object in window because some browsers don't support the performance API at large. And you're also going to want to check if the get entries by type return length is greater than 0 because in the case of paint timing, it may not actually have any metrics, and if you're trying to operate on something that you're expecting but a browser won't provide because the browser doesn't support it, then it's no good, and you might actually have a critical error that halts execution. So finally, you're going to want to gather performance metrics with Performance Observer, and the reason for this is that things like long loops, for eaches, and that type of thing can be blocking, and if you have a lot of resources that you are iterating over, that can block the main thread as you're processing them. So a performance observer simply, what you do at the bottom is when you, oh no, I went back, there we go. When you observe initially, you can specify a number of entry types, and you can see here that there's navigation, resource, paint, and long task, and as those entries come into the observer will reveal them. And then in the observer, you can do some light looping over things or however you want to process that stuff, and then you can work with that data rather than blocking the main thread by messing with it. Finally, I can wrap up. Woo! That was a long one. That was a lot of chatting. Thank you for checking that out. I want to give some thanks to Estelle for putting together this conference. It was a wonderful time. Thank you so much. And lastly, I want to thank all of these people on here who have contributed to all of these specifications. They do incredible work. They're the unsung heroes of performance APIs and performance in general. And lastly, Paul Irish for looking over some of my slides and gut checking some of my assumptions. And thank you for coming. Here are my slides. Have a good day.